Nature-inspired, from animals. Winglets, the tips at the end of the wings of airplane that point upward, were inspired by the upturned wingtip feathers of soaring birds such as buzzards, eagles, and storks. These soaring birds' wings combine maximum lift with minimum length by curling up their feathers at the tips until they are practically vertical. Winglets copy the upward curl of the feathers to help planes fly efficiently and also to keep the length of the wings within limits set by airports, particularly handy with very large planes. Winglets minimize drag by reducing the size of the vortices. Moreover, winglets also create a form of thrust that counteracts some of the normal drag of the airplane. A jet plane in flight creates rapidly spiraling swirls of air at the tips of its wings. These vortices cause drag, increasing fuel consumption. They also buffet planes that may be following closely. Thus, flights departing from the same runway must be sufficiently spaced to allow time for the vortices to dissipate. Naval ships and submarines including commercial vessels experience fouling, which reduces efficiency. Fouling is the accumulation of unwanted material on solid surfaces, in this case algae and barnacles on the hull. It was observed that sharks were the only marine animals that don't foul or they stay clean. This was because shark skin is comprised of denticles that overlap in a diamond-shaped repeating pattern that inhibits bacteria from growing. Scientists realized they could mimic shark skin and create surfaces that prevent bacteria not only on ships and submarines but on medical devices as well. Today, Sharklet Technologies develops medical devices and consumer applications utilizing the Sharklet pattern. Japanese trains can reach 350 km per hour or more. This high speed creates a thunderous noise when leaving tunnels and breaking through the barrier of tunnel air and outside air. To address this problem, engineers look to the technique of the Kingfisher, which can dive at high speed into the water with no splash. By equipping their trains with a Kingfisher beak-shaped nose, the researchers were able to alter the air pressure at the exit of the tunnels and reduce noise. The train became quieter and more efficient, requiring 15% less energy while traveling even faster. Most whales and other cetaceans have flippers with smooth leading edges. However, the humpback whale is different. It has uniquely large bumps, called tubercles, on the leading edge of its flippers. As the humpback swims, water flows over the bumps and breaks up into a multitude of vortices. The bumps channel the water flow and create turbulence. This tubercle effect provides the whale with more lift, allowing it to tilt its flippers at a high angle without stalling. At high angles these bumps also reduce drag, an important benefit for the humpback's long flippers, each being about 1/3 of the whale's body length. Researchers replicated the tubercles onto the blades of the wind turbines, resulting in a 32% reduction in drag and doubled performance. Many times, human inventors only repeat what plants and animals have been doing for thousands of years. This copying from living things is so prevalent that it has been given its own name, biomimicry or biomimetics.